Okay, 3-1, day 2. We're going to do two things. We're going to find a tangent line, which is really what we're looking for. And the normal line is basically just the perpendicular line if you want to change that wording. But I want you to know it if you see that wording. Normal line just means perpendicular. The formula I like to use whenever you're looking for an equation, this is the form I use. I believe your book made a slight alteration to that form and just added the y1 over. And that's completely up to you. But remember, it's just asking for an equation, and if you take a look at these particular directions, does it say what form the equation has to be in? No, it doesn't. Sometimes it will, sometimes it won't. This here is called what in red? Point slope form. Okay. You need then a point and the slope, correct? At, somewhere. But if these are going to be curves, well, then we kind of need them to match up. So what this first one is saying is basically there is some function f of x. Do we know what it is based on the information you have? Do I know what f of x is? Nope, I don't have an f of x. I'm just making the equation of a line that happens to be on f of x somewhere. This notation, this is really what I'm working on now, is so that you know the difference in these notations. What that meant is somebody decided to put 2 in place of x in the original function. How do I know that's the original function? Yeah, no prime. Yep. So somebody decided to put 2 in place of x, right? And what did they get as a result? So what does that really mean? That means I have a point that if I put in 2, I better get -3. Do you agree with that? Yes. And seeing that was the original, that's just an ordered pair, right? Then how come over here it's completely different? That's the derivative. What that's saying is I calculated the derivative, just like we would have yesterday, right? That limit process. It's that answer to a limit process. And they're saying, okay, well, I'll put 2 in there. How come it's not also -3? Well, because now what is this answer right there really telling us? It's telling us the slope. And it happens to be, do you see how it's on the same x value? Because remember, derivative is with respect to some particular x. Okay? Normally when you take the whole derivative, it's with respect to whichever x you wanted to put in. Well, here this problem decided to put 2. So do you agree in this problem, if I'm at that point right there, 2, -3, the slope is 2? Are you in agreement with that? Because this answer right here is 2. Okay. And so if I know a point and I know the slope, can I get an equation of that line? I can. It's actually quite simple, because this is your x1, y1, and there's basically m. And so you just go ahead and you say y minus whatever y1 is, which is a -3, equals 2, because I'm putting in m now, and x minus whatever x1 is, which is 2. And you probably want to go ahead and get rid of that subtract a negative. That just looks silly. And just make it a plus. So once again, then you look back. Okay, is that an equation? Is it an equation of a line? In fact, it happens to be the equation of a tangent line. Now,
Mr. Eichmann, please report to the middle school conference room. Mr. Eichmann to the middle school conference room. Thank you.
Letter B says the normal line, and what we're going to do is we're going to use the exact same point, but we're not going to use the same slope. Because normal line was what again? I said it several times. Perpendicular. So I'm not going to use 2 as my slope. I'm going to use, well, I shouldn't say or. I'm going to say instead, I want it to be perpendicular to that tangent line. And so I'm going to use close, not quite 1/2, but -1/2, because you have to flip it over, because it's 2 over 1, right? So you flip it over, makes it a half, and you change the signs. Okay? But you're going to use the same point, because I want it to go through there. So y, do you understand where the +3 would come from again? If I'm using the same thing? Okay. Equals?
So you don't change the signs at all?
Nope, it's still the same point. And now, right? -1/2, x minus 2. Do you agree that lines A and B would be perpendicular to each other? And they would hit each other at point 2, -3. Yep, and that's what they're looking for. Tangent line, normal line. The key here was really not necessarily point slope form, because let's face it, in Algebra 2 and Advanced Math, we did tons of that. But the key was knowing the difference between f of 2 and f prime of 2. And if you made that distinction here, you're off to a very good start. Any questions? Now we're going to do the same thing. And you're not quite to shortcuts, but you're awfully close to shortcuts. But this will definitely gain some respect because there's multiple x's in here when we do it by the definition. Now, how come I have to do this one by the definition? Because what do you need to use that formula in red up there? You need a point and the slope. Can I get the point without taking the derivative? Yes, it's 1 comma. Well, we have to figure that out. How would you figure it out? 1 comma something, correct? And you would figure it out by, yeah, substituting it in for all x's, correct? So in other words, finding f of 1. And so you put 1 in there, and what do we find out? 2, right? Because it'd be 2 minus 1 plus 1. So 1 comma 2 is the point. Because I substituted 1 into the original, that's why it gave me a y value. Agreed? Well, now I have to go find f prime of x. But unfortunately, to find that derivative, it's the answer to a limit problem. And it's the answer of again, I'm hoping you're getting to the point where you can write that on your own. There's a prime there. It's not a very good one. Okay. I'm going to have to write just a little bit smaller here to get this to work out. The reason I need to do this is I need slope. And we need to figure it out. Ready? All right, so this right here, again, we'll kind of color code it. It's saying put x plus delta x into the function, correct? So I got to put x plus delta x in there and in there. Here we go. Limit as delta x goes to 0. I'm just going to run out of room, I think, so that's why I'm writing small. So do you agree we're going to start with this first one right there? So put a 2, and then that x squared is going to get replaced with x plus delta x, which has to be squared. Everybody understand why I did that? Okay. Now it has a minus x here, so watch how I do this. Be very careful. Minus x plus delta x. And then, yeah, don't forget the plus 1, because that's where you could run into trouble, right? Because if I don't have that plus 1, do you think it's going to cancel off with a negative 1 that's coming later? No, and then you're like, what happened? Because you know everything without a delta x better go away. Well, how am I going to get a minus something? Well, do you agree what I just put in this black box over here is just this first part, right? So we'll color code things and go, maybe blue. We got to do this yet. So minus, again, I love putting parentheses there. I'll put some kind of grouping symbol there. Minus, well, f of x. So 2x squared minus x plus 1. I made it. All over delta x. And now really, this function's not all that hard either, is it? But definition, big pain. Okay, shortcuts you would have been done a long time ago. It's one of those 2 seconds, maybe 3 seconds on a bad day. So limit, because I can't substitute it in yet. So here we go. Is it okay if I just write down the FOIL version of x plus delta x for you? Are you getting pretty good at that? I hope. Right, I'm going to write down the 2 though. Everybody see where that 2 is coming from? That original one. So it's x squared plus 2x delta x plus delta x squared, right? If I ever get going too fast, let me know. I think some of you are actually ahead of me at this point. What's probably very important on that next piece here? Yeah, distribute that negative. So we've got minus x minus delta x. Did everybody see that? Plus 1. And another thing that's very important is this last part, distributing that negative. So negative 2x squared plus x minus 1. And for sake of room, I hope it's okay if I go in and cheat a little bit. I think it's that one. I can't really see. I'm going to go distribute this 2 if it's okay. Ooh. All right. So let's try this. This would be a go away. 2 4x delta x, right? And 2. Sorry about that. I just was running out of room real fast. Do you agree that I distributed that 2 properly? Okay. Wow, that got pretty long. Yeah. And so hopefully you're starting to gain some respect for the shortcut. Because imagine throwing something this size with the one rational one I gave you, which is the easiest rational one there is, that the common denominator was a problem for you. Imagine throwing something like this as just one of your numerators. Mm-hmm. So what should happen to this? Does it? Yes. Does this have to cancel, this 4x delta x? Does it combine with anything? No, because you have to have an x delta x to combine. Nope. 2 delta x squared. Nope. Minus x. And plus x. Minus delta x. Does that combine with anything? Nope. Plus 1. Minus 1. Gone. So limit as delta x goes to 0. Whoops, bad arrow. There we go. Let's, is it okay if I factor out the delta x as I go? So we got what, a 4x plus 2 delta x minus 1. Very good. Did everybody see where the negative 1 came from? Very important not to forget that.
Why is that minus 1? Because it's an understood.
Delta x divided by delta x is 1. And it's negative. So it's negative 1. So put 0 in there. So the answer is once again, your shortcuts, you would have done that in approximately 2 seconds. But we have a slight problem now. Yeah, that's just the derivative. That's not even what they asked for. I asked for the tangent line and the normal line. A good thing that's not going to take too long. Because we have the point. Do you agree? What's the point we're looking at? How did we figure that out? We put 1 in the original, correct? How are we going to find out slope at 1? Put 1 in the derivative. And so if I put 1 right about there, and I'm choosing 1 because it says so right here. All right? Put 1 in there, and we've got what for a slope? 3. All right. Now, the reason this isn't going to take long is tangent line, I'll just put it right up here. All you do is go to the formula then. Y minus 2 equals 3 and x minus 1, right? Because once you know those two things, it's pretty quick because I'm not asking for slope-intercept form or anything like that. In normal line, are you still using 1, 2 for the normal line? Yeah, I want them to be perpendicular to each other. But I'm not going to use 3, I'm going to use negative 1/3. Yep. So y minus 2 equals negative 1/3 x minus 1. We needed the slope. How else were we going to get it? Substituting the value into the derivative. Because that's what derivative tells you. Slope. 1. The x value was 1 that I was looking for. Put it in here. Get me 3. Because what if I would have asked at a different x value? Would the slope have changed? What if I said an x value of 3? Is the slope different? Yeah. And would the y value have been different? Well, yeah, I would have had to put 3 in here, and it would have been a completely different y value, completely different slope, completely different equations. Okay. Just keep in mind, you're close to the shortcuts. Yes, question? How did we get what? Well, the x value they wanted to know an equation, that was 1, so I put 1 into the derivative. So, any questions on that? That's a statement, not a question. Just because you put an inflection on it doesn't mean that it's a question. Mm-hmm.
See, when I was listening to this, I was so confused because there was some talk.
All right. If you can do this, I think you've got a pretty good idea of what is happening here. Now, what I don't want you to do is, because you are just so smart, you actually know what these parent graphs are, correct? You know that's x to the third. But what I want you to do is start thinking of the slopes. Because this is the derivative, right? The y values down here are the slopes of the same x values up here. That's what it means. So just pick some x value. Like, for example, if I chose this x value, do you agree the tangent line's kind of going across like that, right? And so that slope is about what? It's about 0. So at an x value of 0, the slope should be 0, which means the y value down here should be. So is this one a possibility still? A. Is 0, 0 a point? How about this one? Is 0, 0 a point for B? Is 0, 0 a point here? So basically, have we eliminated any options? No. So that point was a horrible one. Why did we choose that one? So let's try over here. Let's try, I don't know, over at maybe 3. If we go up here, do you agree the tangent line is something like that? Pretty steep, right? Maybe but it's positive. Do you understand that, right? 3 comma positive, I don't know, maybe 3 or 4 or something like that, right? Maybe? And so if you're going out, so it's 3 comma, it should be something positive though, right? So go down here, is this 3, and then does it go up to something positive for a y value? Well, this one, 3 positive, okay? But that's not too high, but this one, 3, not possible. So how do you suppose we're going to figure out? Oh, try a negative. We're trying to find which graph is the derivative without giving you the function. You just choose any ones you want. So let's go over here. Let's try, should we try negative 3? So you go negative 3, well, wait a minute. Is that slope positive? So if I go to negative 3, I'm supposed to get a positive slope? So wait a minute. If I go to negative 3, this goes down to a negative value, doesn't it? That's not good. Because the y value of this one is the slope of that one. What's the y value right here, Tabitha? Is that a negative 3 slope? Oh, that's a huge positive slope. Rising from left to right? Positive, big time. Doesn't matter where it is, you're looking at the slope. Is that slope positive or negative on that line right there? Is this a positive or negative slope? Positive or negative? Which one matches up with that one? There you go. All right. So at negative 3, this gave me a negative y value, which meant that slope needed to be negative. Is it? Over here, negative 3 comma something gives me a positive y value. Is it a positive slope there? Yes, it is. Yes. No, the question was, if our original had a curve, doesn't the derivative have to have a curve? And no, because the derivative of, if I did the second derivative or the derivative of b, it'd be a line. So.
No, but you're not looking at the slope. You're looking at your y.
In derivative, you look at y value. The y value of the derivative is the slope in the original.
Okay. I get what you're saying.
Well, if you're unsure, why don't you try this one? All right, let's take a look. So which of the following graphs, for each of the following graphs, determine which graphs could be the graph of the derivative. So, for about the 10th time, whatever the y value is down here, it's telling you the slope of the same x value up there. So pick an x value, any one you want, I don't care. 4. So you go out to an x value of 4. Do you agree the point's way up here?
Yeah.
We need to find the slope of that line. Do you agree? Is that slope positive or negative? So if I go to an x value of 4 down here, 1, 2, 3, 4, the y value better be positive. Uh-oh, it's a negative y value. No good. How about we go to 4? 1, 2, 3, 4. We go up, is that a positive value? How about we go to 4? 1, 2, 3, 4. We get, oh. So we should try another point to try and eliminate another option. So do you have to do the same? Does it have to be -4 because I chose +4? Well, you can try -2, you can try -1, whatever you want. So -1, 2, 3, 4. Oop, yep, I got it. That slope there is most definitely. So if I go to -4 down here, I'm supposed to get a negative value, do I? -4, negative, do I? Based on your knowledge, could it be B or C? Yes, based on your knowledge, it could be B or C. But many of you heard me say that this was going to be a line, which is why I'm going to give you another bit of information. When you take the derivative, the power will go down at 1, basically. So do you agree this is x squared? So if the power goes down 1, you're down to x, right? Which is a line. If you get to this, do you agree you would have had to have gone up a power to get to that one? But based on the information I gave you, would you have known that? No. I wanted you to strictly look at slopes. Okay? Because that's what the derivative tells you is slope. Okay? Technically, with your knowledge, it's B and C, but the best answer is C. Because C is actually the right answer. Okay? Again, slope of the original is the y value in the derivative. Because what is the derivative? The answer to a limit problem that deals with slope. Any questions?